particle accelerators have revolutionised the modern world. Studying viruses, making smartphones, nuclear power generation, sewage sterilisation, MRIs for cancer treatment, ice cream and chocolate. Yeah, not kidding. The multitude of richer and smoother desserts today is thanks to X-ray imaging of crystal structures in foods to avoid chalky or icy parts. This is why particles are worthy of multi-billion-dollar experiments like the Large Hadron Collider at CERN. And since the discovery of the Higgs boson in 2013, we now have a theory of matter and energy that's changing the world faster than the line for the next iPhone. Welcome to the standard model of particle physics. Greek philosopher Democritus introduced the idea of the atom almost 2,500 years ago, a fundamental point that cannot be broken down into smaller constituents. It wasn't until the 1800s when British chemist John Dalton formalised the theory of the atom.
Or anthropismo.
But we now know it's not the smallest thing there can be. Much like how Dmitri Mendeleev constructed the periodic table of elements, scientists began peering into the atom's secrets in 1897 with Joseph J. Thomson and his cathode ray experiments. Here's how that worked. Using a glass tube evacuated of air, a cathode is placed at one end of the tube and an anode at the other. As a voltage is applied to the circuit, a beam of energy will flow through the tube to reach the anode. This is called a cathode ray for that exact reason. Thomson placed two electrodes near the end of the ray, one positive and one negative. The ray would bend towards the positive electrode like this, indicating that the ray has a negative charge. Thomson did the same with a magnet and found similar arcing of the ray. Setting up both the electric field and the magnetic fields so that they deflect the ray at the same angle allowed him to calculate, with this formula, the charge to mass ratio of the particles making up the ray. The negative 1.76 times 10 to the 8 coulombs per gram he calculated was over 1,000 times lighter than the hydrogen ion, the lightest known atom at the time. Thus, the electron became the first subatomic particle ever discovered. My videos would just not feel the same without mentioning my favourite physicist, Einstein. Up until 1905, light was thought to be a wave. However, an experiment proposed by Einstein suggested light also had particle characteristics. The photoelectric effect and its experiment not only proved the existence of the photon, but introduced through experimentation particle-wave duality, a function of quantum mechanics. It won him the Nobel Prize in Physics, which is funny, since he is most well known for his masterpiece of general relativity, which did not win a Nobel, but did win the respect and admiration of the entire world, and in honour of his contributions, an element to be named after him, Einsteinium. I will cover the photoelectric effect and the discovery of the photon next time. If I've earned your subscription, cheers! To be alerted of future videos, hit that bell looking icon next to the subscribe button below. I'd like to give a special shout out to my Patreon Alison Cornish. Thank you so much for your support. If you would like to join Alison and I on more science madness, check out patreon.com/JTheoryScience. Thanks for watching, and take it easy.